Nice. All right. So a couple things that we do need to know, okay? If I have a rectangle, how do we find the area of a rectangle? Length times width, good. If I have a square, how do I find the area? Length times width or S squared, good. And then if I have a circle, hey, how do I find the, Savannah? At 2:15. If I have a circle, how do I find the area? Pi r squared, awesome. A lot of people want to say 2 pi r here. What's 2 pi r? Circumference of a circle, so the distance around. So circumference is just like perimeter, but just of a circle, okay? Now, we have a photograph, okay, that is 8 inches wide and 10 inches long, okay? If we have a photograph that's 8 inches wide and 10 inches long, how or what shape do we have? A rectangle. Okay. So we have it 8 inches and we have 10 inches. Okay, and there's my photograph. Okay, I'll draw a little smiley face. There you go. There's my photograph. All right. Now we're going to surround it by a border that is 2 inches. Okay, so now it's kind of like I'm going to put a frame on this picture in a frame. And we know if I add this frame, I'm adding what to the length and to the width? 2 on each side, right? So now the new length and new width of this with the border is what by what? 10 inches by, no. So we both said 10 inches and 12 inches. Is that correct? No. It is 14 inches and 12 inches. Why? Because we're adding 2 to the left, 2 to the right. So we're adding 4 inches to both sides. And we're adding 2 inches to the top, 2 inches to the bottom. So that adds an extra 4 inches. Okay. Now, find the area of the border. So I just want this area of the border. Do I want the area of the whole thing? No. Okay. So if I want the area of the whole thing, okay, so the picture with the border, what are my dimensions again? 14 by 12. And how do I find the area of that entire border? We multiply. So the area of this entire border is 12 times 14, which is what? 168. Okay, so that's this entire thing. Is the entire rectangle my border? No. But we do know we can find the area of the photo. And what do we know about the photo? It is 8 by 10. And how do I find the area of this photo? Multiply 10 times 8, which is 80. So that would be the area of this. Okay, is everyone okay with this? Now, if I have the area of the whole thing, I have the area of my photo, I want to take away the photo, don't I? I'm going to cut the area away. So what do I have to do with the two areas? I'm going to subtract the 2. So 168 minus 80 is 88. So the area of my border is 88 what? Inches squared. So the whole idea here today is we're going to find the areas of the bigger, the areas of the smaller, and then cut them out from each other. Okay? Does that make sense on why we do that? Subtract the 2? Yeah, okay. All right. Now we're going to add a little bit to this. Here we just dealt with numbers. Now we're going to deal with variables. Okay. One thing I have to say here, okay, do you guys know why it's inches squared? Go ahead, Sarah. We're multiplying 2 sides, right? 8 inches times 8 inches. What's x times x? X squared. So what's inches times inches? Inches squared. Inches squared. When we talk about perimeter or circumference, it's always just inches, right? Because what's x plus x? 2x. So if I have inches plus inches, it's going to stay inches. Right, well, 2 inches, but yeah, it would stay inches in that sense. Okay. All right, next one. All right. Hector made a rectangular fish pond surrounded by a brick walkway of 2 meters wide. So we have a fish pond, right? There's my fish pond. Here's my fish. Okay. There's my fish. Okay. And from that, he made a brick walkway, right? Does that brick walkway go all the way around the fish pond? Yes, it does. Yep. So we're going to have a brick walkway. So this is kind of bricked. So we got a brick walkway. All right. And we know the brick walkway is what? 2 meters each direction, right? So this is by 2, this is by 2, this way's by 2, this way's by 2. Okay. You guys okay with that so far? All right. Hector had enough bricks for the area of the walkway to be 76 square meters. So the area of what is 76 square meters? The walkway. So this green area is what? 76. So the green area is 76 meters square. Well, how do we get the area of just the brick walkway? Savannah? Yeah, so we're going to take the area of the big, then we're going to find the area of the small, which in this case is our fish pond, and we'll subtract the 2, and it should equal what? 76 meters squared, right? Okay. Now we need to find out a little bit more information, don't we? So let's keep reading. Find the dimensions of the pond. Okay. If it is twice as long as it is wide. Well, do we know how wide my fish tank is? No. So we are going to label that as, how about W? Are you guys okay with that? Yeah. So if my width of my fish pond is W, what is the length of my fish pond? 2W. So I have my length and my width of my fish pond. So can I go ahead and find the area of my fish pond? Yes. What is the area of my fish pond? 2W times W, which is 2W squared. Good. Are you guys okay with that? We know that equals 76. All right. Now, we need to find the area of the large, right? So we need to find the width of my entire thing. So if the width was W and we added 2 to the below it and 2 above it, what would that new width be? W plus 4. Good. You guys okay with that? Now, if my length was 2W and I add 2 to the left, 2 to the right, now my length is 2W plus 4. Good. All right. So now, can we find the area of the big, what we're given? Yeah, what's my length? 2W plus 4 times, what's my width? Bless you. W plus 4. Okay. So now, how would I multiply W plus 4 times 2W plus 4? I'd have to FOIL it, wouldn't I? So to get this one, we need to FOIL. Or distributive or table, however you want to do it, okay? What's 2W times W? What's 2W times 4? 8W. What's 4 times W? And what's 4 times 4? 16. Okay. Now, can we combine like terms there? Yes. So we're going to have 2W squared plus, what's 8W plus 4W? Plus 16. And I'm going to keep that in parentheses because that's the area of my big, right? Minus, what's the area of my small? 2W squared equals 76. Now, can we solve for W? Yes. Yes, we can. What happens to those 2W squareds? They cancel. If you have W squared, X squared, they should always, always, always cancel. If not, you did something wrong. Because have we learned how to solve equations with squares? No. So those should always cancel out. If they don't, again, you did something wrong. Okay? Yes. Inside and outside. So 2W times 4 is 8W. And 4 times
Mrs.
W is
Cochran.
4W. Okay. So now we have 12W plus 16 equals 72. And then what?
Mrs. Cochran.
Yeah.
How'd you get the 72?
Because it's because it's supposed to be 76.
Oh, all right.
You see why I'm supposed to have 76? I don't know. 72 sounded like a good number. Sorry, 76. All right, now what? Subtract these 16. And what's 76 minus 16? 60. And then what? Divide by 12. So W equals 5. What does W represent? The width of my fish pond. So my width of my fish pond is 5 what? Meters. And then what is my length of my fish pond? 10 meters. Why? Because it's 2 times W, right? Did we answer the question? Find the dimensions of the pond. Is 5 and 10 the dimensions of my pond? Yes. Yes. Thank you, Andrew, for telling me that I messed up. Okay. I think first block today messed up on a problem. No one told me until the end, and I'm like, this isn't the right answer. It's supposed to be an even number. I'm like, oh, and they're like, yeah, I noticed that. I'm like, why didn't you tell me? Why did you let me keep going the whole time? We all make mistakes. It happens. So please let me know if I do make a mistake. I teach too many classes to keep it all straight. All right, a rectangular 5 centimeters longer than its width. Can we make a rectangle that is 5 centimeters longer than its width? Yes. Yes. Not drawn to scale though. Okay. Not drawn to scale. Okay. That does not look like centimeters. All right. So what do you want to label the width? W. What do you want to label its length if it's 5 centimeters longer than its width? W plus 5, 5 plus W. Does it matter the way you have it? No, I always tend to go standard form though. Okay. If its length and width are both increased by 3, so we're just increasing by what? 3. Are we doing it to both sides? No, we're only doing it to one side. We're extending my width 3 centimeters, right? So what would be my new width of my new rectangle if I extend it 3 centimeters? W plus 3. Then I'm going to extend my length by 3. So now what is my new length? W plus 8. Okay, you guys okay with that? So now this is my new rectangle. Okay, you guys okay with that? All right. Now it is not a border, so that's why I didn't add it to both sides. Okay, it's just extending the length, extending the width by that 3. Okay. Now, if its length and width are both increased by 3, its area is increased by 60 square centimeters. So my original rectangle is this one in the purple, right? If I find the area of that, what would I get? What is the area of my purple? Area of my original. Right, W times W plus 5. And as they said, was W squared plus 5W. So that is the area of my original. You guys okay with that? Now, when I extend it to make this red rectangle, this area is doing what? This area is increased. So if this is my area of the purple and I'm increasing it by 60, what would I do to this? Add, Hunter, put it away. Add 60 to it, right? So this here is my original area, and then adding 60 gets my area of my new one, right? So this together is the area of my new one. You guys okay with that? Okay. So since this whole thing is the area of my new, okay, can I find the area of my new with my original information? Yeah. So this area of the new is from my purple rectangle, right? Now, to find the actual area of my new one, which is the red one, what is my length, my width? W plus 8 times W plus 3. Could I find the area of that? Yeah, and what's the area of this one? W squared plus 8W plus 3W. Does it matter the order these are in? No, he just spells FOIL wrong. And then 8 times 3 is 24. So can I combine like terms? Yes, what's 8W plus 3W? 11W plus 24. All right, so this is the area of my new with the new dimensions, right? This is the area of my purple added on the area to match my new, right? So what can I tell about these two areas? They are equal to each other, right? So these are equal to each other. Okay. Since we increased the first one by 60, that said it would be the same area, correct? Yeah. So now, can we solve this? Yeah. What happens to these W squareds? They cancel out. How do I move 5W over? So what's 11W minus 5W? How do I bring 24 over? Subtract it, so I get 6W equals 36. Divide by 6, so W is 6. So my original, because it said find the dimensions of my original rectangle. What is my width? 6 what? Centimeters. What is my length? 11 centimeters. And there you go. Did we find the dimensions of my original? Could you find the dimensions of my new one? Yeah, what's my new one? 14 and 9. Yep, 14 and 9. Right, any questions with that so far? No. All right. A rectangle is 10 meters longer than it is wide. Okay. If its length and width are both decreased by 2, its area is decreased by 48. Okay, and you guys can't see that on the board. There you go. All right, so we have a rectangle, right? What can you guys tell me about my original rectangle? Right, so how wide is it? W. What is my length? W plus 10. Okay. So can we find the area of my original? Yeah, we can. We can find the area of that by taking W times W plus 10. So that would be W squared plus 10W. Good. Okay, is everyone okay with that? So that's my original. Now, we are decreasing by 2. So each side is being decreased by 2. So my length is coming in by 2, right? So now my new length is what? W plus 8, good. And my width is decreasing by 2. So now my new width would be W minus 2. Okay, you guys okay with that? Now, if we look at this, obviously that's not the best drawing, but we get the point, okay? The area is decreased by 48. So my original area is now what? Minus 48, because my original area is decreasing by 48. So that's why it's minus 48 to my original. Okay, you guys okay with that? Okay, now can we find the area of my new rectangle? Yeah. What are my two? Length and width? W minus 2 and W plus 8. So let's go ahead and FOIL that. W times W is W times 8, negative 2 times W, and negative 2 times 8, negative 16. All right, what's 8W minus 2W? All right. You guys okay with that? So this is the area of my new. This is the area of the new when it was decreased. The old was decreased by 48, right? So what's true about these two areas? They are equal to each other. Okay, because it says the length, because this is the area of the new, right? And it said the original area is decreased by 48. So if this is my original, right, that W squared plus 10W, it's decreased by 48. That will get me my new area. Okay. Now what happens to those W squareds again? Hey, Sophia. They cancel out. Okay. Now, do you want to move the 6W or the 10W? The 6. So how would I move the 6? Subtract it. So I get negative 16 equals 4W minus 48. I don't know why I have plus 48. Minus 48. And then how do I move the 48? Add it. So 4W equals, no, 32. Negative 16 plus 48. And then divide by 4. So my width is 8. So my original width is 8. 8 what, meters? Okay. So my width is 8 meters. What would be my length? 18. Because it was W plus 10. And there's your original. Okay. Any questions with that? Sophia, did you have a question? Could I see you? I saw you pop on real quick.
Oh, no, that was an accident.
Okay, not a problem. All right, any questions with the rectangle ones? All right, here's the hardest one. All right, so we have a running track. Okay, so we have a track here. The track is technically an oval, isn't it? But do we have a formula for an oval? No. Okay. So we have a running track 4 meters wide and goes around a soccer field. What shape is a soccer field? A rectangle. So I'm going to go ahead and start with a rectangle. And here is my soccer field. All right. And that soccer field is twice as long as it is wide. So how wide is my soccer field? W. What is its length? Okay, is everyone okay with that? Okay. All right. At each end of the soccer field, the track is a semicircle with an inner circle of radius. Okay. You guys okay with that? So now I'm going to change this. Okay. Because what is the shape from here to here? What is that distance? The radius, which is R, right? So do we want to have 2 different letters in my equation? No, that'd be kind of confusing. So if this from here to here is R, what is it from here to here? R, right? I'm just gonna look at R. So what's R plus R? W, what's R plus R, guys? How about 2R? Can I do 2R? Yeah. We have a circle, and circles use radius, right? So I'm going to keep radius in my equation. Does that make sense? Yeah. Yes. So then what would my length be if now my width is 2R? 4R. So I'm going to change this now to 4R. You guys okay with that? Okay. Now, we have this track around. And we know we're extending it what? 4 meters each side, right? You guys okay with that? Now, we want to find the area of just the track. If you look at this, what 2 shapes do you guys see? I see semicircles, which could be circles, couldn't they? And I see I see a rectangle. But remember, a radius is from the center to the side. So we know from here to here is R. From there to there would be R. So what's R plus R? 2R. Okay. You got it? Okay. So do you guys see a rectangle and a circle? Yeah, so I'm going to split this up. So I'm going to take it here. So we have the rectangle, right? You guys okay with this? And do we know how to find the area of the shaded part? Yeah, because we take the area of the whole, the big thing, find the area of the small, and then do what with them? Subtract. So let's go ahead and find the area of the small first, which is the soccer field. You guys okay with that? All right, so what's my length of my soccer field?
8R.
Okay, you found the area, but what's my length? 4R. What's my width? 2R. So my area would be 8R squared. Okay. You guys okay with that? Okay. Now, let's go ahead and find the big area. Okay. So let's find the big area. So the big rectangle. All right. So my length is still going to be what? What is my length? 4R. Now my width is what changes because we're adding what to each side of my 2R? 4. So my width now is 2R plus what? 8. Why is it 8 and not 4? Because you're adding 4 to the above and 4 to the below it, right? So can I find the area now of my big? Yeah. So what's 4R times 2R? 8R squared. And 4R times 8? 32R. Okay. So now we have our big and our soccer field, the small. So what do I do to these 2 areas to just find the blue? Not set them equal, subtract, right? So we're taking 8R squared plus 32R minus what? 8R squared. So what is my area of the blue? Just 32R. So this is the track. So this is the track in the rectangle part. Does that make sense to you guys? Okay. Now, we need to look at our circles now. Okay. If I look at this side and this side, doesn't that make one big circle or one small circle? Yeah. So can I find the area of my small circle? And how do we find the area of a circle? No, pi r squared, right? What is the radius of my small circle? No, what's my radius? R. It's just r, isn't it? So isn't the area of my small circle just pi r squared? Yeah. Yeah. All right, now the area of, now let's look at the track. So the big circle, right? You guys okay with that? Yeah. Now, looking for the area of the big circle. We're going to do pi r squared still, right? Now, we have to figure out what our radius is, okay? In this case, remember, the radius is from the center to the side, correct? Well, what is it from the center to the little circle? R, that's not what I asked. What is it from the little circle to the edge of the track? 4, so what would be the whole radius? R plus 4. Okay, is everyone okay with that? Okay, now R plus 4 squared is not R squared plus 16, is it? No, because R plus 4 squared, doesn't that mean R plus 4 times R plus 4? Yeah, because the square says that occurs how many times? 2 times. Already put it away, please. Now, what do I have to do here? I have to FOIL it, right? So I'm going to leave the pi on the outside. So what's R times R? What's R times 4? 4 times R? And 4 times 4. All right, so what do I get inside there? R squared plus 8R plus 16. Now, how do I get rid of this pi? Nope. I multiply everything by pi. I distribute it, right? So isn't this pi r squared plus 8 pi r plus 16 pi? You guys okay with that? Okay. So now this is the area of the big, right? The area of the big. This is the area of the small. We need to cut the small out, right? So what do I do with these two areas? I need to subtract. So I'm going to take this pi r squared plus 8 pi r plus 16 pi and subtract it from what? Pi r squared. Whew. What happens to these pi r squareds? And you guys can't see that. Sorry. They cancel out. So I'm left with 8 pi r plus 16 pi. So this is, so we have the area of the track is 32r over here in the rectangle. We have the 8 pi r plus 16 pi is the circles here. So what would I do to get the area of the whole thing? I would add them up. Yeah. So we're going to add the two. So my track is 32R. And what's my track of the circles? 8 pi r plus 16 pi. Can I combine any of those? No. Why not? Because they're unlike terms. Exactly.
Question, real quick.
Yes.
How did you cancel out the pi r squared again?
Pi r squared minus pi r squared.
I know, but like, why did you add that extra pi r squared?
This one we're